So again, what I started to talk about a little bit when we were doing functions, and I want to go through that a little bit more clearly, is the idea of domain and range. And so we had, if you guys remember, we started off our functions here, talked about, this being a function being a big dumb machine, and inside that machine, it oftentimes does equations. But the stuff that we drop into the function, that is called the domain. And the stuff that it spits out, that's called the range. Now, sometimes there are things that you cannot put into the function. So, for example, if I were to change this function to, let's say, if the function f of x was the square root of negative x, okay, that would be a problem for an input of 5, because then the output would be the square root of negative 5. That's not a real number. So therefore, we could not have 5 in the domain of the function. Sometimes the domain is limited. I could put negative 5 into the function. That would be okay, but I couldn't put positive 5 in there. So when you're looking at functions, the domain being the input and the range being the output, remember the domain are the x values and the range are the y values. So for example, in these pictures that we did, let's say that this graph stopped here and stopped here. So it does not continue to the right or to the left. Well, the domain for the graph, we could see as if we were to take the graph and like squish it onto the x-axis. So like if we brought all these values down here, okay, and all those values up to the x-axis, how much of this x-axis would be covered up? That's our domain. We're squishing it onto the x-axis because those are the numbers that you can plug into the function because they'll give you an output. I can put -1 into the function because it has an output of 2. I could put -1 into the function because it has an output here. I could put -2.5 into the function because it has an output. But I could not put -10 into the function because over here there are no output values. So I would then say that the domain of this function, and we would denote that D for domain is going to be everything from this x value to this x value. So that is, sorry, I'm trying to erase that. If these are both included, our domain is inclusive from -5 to +5 inclusive. Okay. Now, if let's say that this on the right side, let's say that was an open circle, well, that just means then +5 would not be included in our domain. Okay, so it's kind of the boundaries on the x-axis from left to right. And the range, the output values, those are the boundaries if we were to squish that on the y-axis. So if we take all this stuff and squish it sideways and all this stuff and squish it sideways, how much of that y-axis would be covered? Like nothing up here would be covered because there is no graph up there. So when we squish it onto the y-axis, everything from this point to this point would be covered by the graph. And so that's the range of the function. It looks like from -3 to +3. So our range is going to be inclusive of -3 to +3 inclusive. All right, any questions on that before I move to a different picture? All right, well, then I'm going to look up here. And I'm going to draw a couple of pictures and just look at our domain and range from a graph. let's say I had a parabola, and the parabola looked something like this. And let's say the vertex of the parabola is here at, how about 2, -4, okay? Now, the nice thing about the vertex of a parabola is it tells me a lot of information about it. First, that's the bottom point. So that's going to be a boundary point for our range. Remember, the range of the output values. The domain, which are the input values, those are numbers that I could put in to get an answer. So for example, if I took this graph and looking at it graphically, if I squished it onto the x-axis, okay, the entire x-axis would be covered up. So our domain is everything from -infinity to +infinity, because the entire x-axis would be covered because the graph continues. Remember, those arrows mean it continues in both directions. Now for the range, if I squished everything to the y-axis, okay, everything from here up is going to be covered, but nothing down here. So I got to think, what is that minimum value? I could look at the vertex of the parabola, and I know that the minimum value is -4. So our range is everything inclusive of -4 to infinity. All right, any questions yet? All right, well, let me give you another one then. Let's say we had a graph that, let's say it was kind of a crazy looking graph. So it starts down here, goes down, goes up, comes back down, and I'm going to give a couple of coordinates here. Let's say this coordinate over here is at -15, -8. Let's say this point here is at 10, 2. And this open circle here is at 12, -11. All right, so we're going to find the domain and range of this function. Now the domain, we're going to squish it onto the x-axis. So if I squish it all onto the x-axis, the left boundary is going to be right here, inclusive. And the right boundary is going to be right here, exclusive. So my domain is going to be everything from -15, sorry, inclusive, to 12, exclusive. And the range is going to be everything from -11, exclusive, because this would be the bottom point here, all the way up to +2, but inclusive because this is a closed circle at +2. Right. Any questions on those two? All right, so looking at, say, this that we know is a function, this is a little bit different, but if I said, what is the domain? Well, the domain are just the x values. Like the domain would be the numbers -2, -1, 0, 1, and 2. That's the domain, the numbers that are the x's. And the range would be the y's, 3, 0, -1, 0, and we already said 3, you don't have to say it again. So just 3, 0, and -1 would be the range of that function. So domain, our inputs are the x's, and range are outputs, and those are the y's.